Hello you all. We are going to do now our first introductory example to the use of Aspen+. Before presenting the case in Aspen+, I show you the example. We want to compress an air stream at ambient conditions, 20 degrees and 1 bar, up to 5 bars. For doing this, we are using a compressor of the type single-stage positive displacement. If you want to do this calculation by hand, by yourself, you need to do an enthalpy balance. You know that the enthalpy of the inlet stream plus the power provided to the compressor must be equal to the enthalpy of the exit stream. So, for this, you need first the enthalpy of the inlet stream. How can you calculate it? You can do it from the specific heat of the gas. But if you want to do it not for an ideal gas, but for a more real gas, you need to use an equation of state. For example, the Penn-Robinson equation of state. For doing this calculation, you only need the temperature, the pressure, and the composition of the stream. You need the power, the enthalpy, which is required by the compressor. You can calculate this from this formula that you can find in any thermodynamics book, for example, the Perry Handbook. You can calculate this enthalpy change from the inlet and outlet pressure and the polytropic coefficient. Once you know the inlet and the power, you can calculate the outlet enthalpy just by the addition of these two terms. Now, you must go through the same way, but on the opposite direction. If you have the pressure and the enthalpy of this stream, using the same equation of state, Penn-Robinson, you can calculate the temperature, the entropy, and all the other properties of the final stream. You must consider that the simulator requires exactly the same information you do. For example, for this example, we need to specify first the components. We have air. Second, the thermodynamic model we are going to use for enthalpy calculations, the Penn-Robinson equation of state. Third, to develop the process flow diagram. In our case, it is very simple. It's just a compressor with an inlet and outlet streams. And finally, we need to provide the conditions of this inlet stream: temperature, pressure, molar flow, and composition, pure air. If we specify now the outlet condition, 5 bars, and the type of compressor, the problem is fully defined and can be solved. If you want to do the same calculation using Aspen+, I will show you how to do it. Go to Start and look for Aspen. Probably you will find different options of software from Aspen. The one we are using is the one named Aspen Plus version 11 in this case. This first screen is just to show you a video about the new features of the software. You can close it. This is the logo of Aspen. If you click on it, it will disappear while the program is starting up. And here it is the program. You have the title bar, the ribbon, la cinta, which changes depending on the position of the program. And here we select a new file. We are using user templates. These are different templates for different software types. Depending on the type of template you select, different units, property methods, bases, and so on can be selected. For this course, we are using always the User General with Metric Units template, la plantilla general con unidades métricas. Click on Create, and the new file will be started. Look here, the title bar now shows the name of the file, SIM01, a general name. At this moment, we are in the environment properties, which is the point where the files always start. Here you must provide the components and the method you are going to use for your simulation. Here on the left you have the Forms Explorer. This is similar to the Explorer used in Windows for looking for files and folders. Es como el explorador de Windows para ficheros y carpetas. But in this case, the folders can contain other folders, but at the end, instead of files, it has forms. This is a form. Form is just the collection of different data for a section. For example, in this case, this is the form for components, is the form specifications, which is in the folder components. It's empty. Some information is required about components for doing the simulation, and that's the reason why the status is red. If I write here the name of my component, air, now the status turns to blue, because with one single component, Aspen can do the simulation. Of course, if you require more components, you need to introduce them below. As you can see, other forms already have blue status. That means that somebody has introduced information on these forms. This has been done by the template we have chosen at the beginning. If you look here, the only folder with a red status, with a non-complete status, is methods. You can open the folders until you find the form which needs to be completed. But another way of doing this is using the Next button, which takes you to the next form to be completed. In this case, it is the form specification methods. Here we need to specify the thermodynamic model we are going to use for our simulation. This first field, este primer campo, is just a filter. By default, por defecto, is common. This means that the thermodynamic models which are offered here are the most common ones. If you choose all, then the number of models which is offered is much larger. You can, for example, select in our case a type of process, in our case gas processing, and the base methods which you can choose are reduced to a reduced number of models. We are chosen in this case the Penn-Robinson equation of state. Now this status is complete, all the status of the forms are blue, are completed, and the general status at the bottom of the system is required properties input complete. We don't need to provide any additional information. If we now click on the next button again, you are asked, what do you want to do? To run property analysis, to calculate properties of your components, to change some of the values, or the last one, we want to go to the simulation environment. This means that we change from properties environment for calculating properties to simulation environment for doing simulation. The two other environments, safety and energy, are intended for safety calculations and energy calculations, but not will be covered in this course. We click OK, and now you can see that the environment is moving from properties to simulation, and the folders and forms in the Explorer are different. For example, components is not present, methods is not present. However, streams has appeared as a new folder. Blocks has also appeared as a new folder. The original screen is the main flowsheet to develop the process flow diagram. In our case, we need a compressor. We look here in the model palette in the bottom to the group pressure changers, pump for liquids, compressor for gases, and so on. We drag, arrastramos, one compressor to the process flow diagram zone, and now we need to connect it. We click on Material Streams, and when we move to the desktop, we see that several ports appear on the block. If you place the mouse on one of them, for example this one at the top, you get some message about information. This is a feed connection for streams. It is required. We click here, and as this stream comes from out of battery limits, como viene de fuera de los límites de batería del sistema, we click at any point in the blank zone. Okay, the same for the exit street. In this case, we have two different ports. Be careful. If you place the mouse on the red port, you read, this is product stream, and it is required. That's the reason why it is red. The second port is not for connecting the product stream, it's for water decant. If some water is decanted in your system, you can connect it here, but this is not the case. So we click on the red port, and we click on the desktop. Well, look at here. If you see in the inlet port, the red arrow has been changed to a blue arrow. That means that you can connect additional streams in this port if you want to do so. Let's click here to go out of the material connection and click on the next button in the home menu of the ribbon. Next. We are in the folder streams, stream S1, which is the inlet stream, input. Here you have some information that you need to provide to complete the status to blue. By default, you need to provide two properties of this stream, in this case temperature, pressure. Okay, we have the stream at ambient conditions at 20 degrees and 1 bar. We know the total flow rate, which is 200 kilomoles per hour, but the status it is still red. This is another use of the next button. When you don't know why a form is not complete, you click on the next button and you receive some additional information. Component flow, fraction, or concentration must be specified. We have a single component, but we need to specify the composition of the stream. In spite, this will be a pure component. We select here that the composition will be expressed in mole fractions and that this mole fraction is 1. Now the status is blue. Press on Next. Now we are in the blocks folder B1, which is the compressor setup. We need to specify if it is a compressor of a turbine, it's a compressor. We need to specify the type of compressor. We use a positive displacement. And we need the outlet specification. There are different options. The discharge pressure, the pressure of the outlet stream, or the pressure increase, or the pressure ratio, or the power requirement. In our case, we know that the outlet pressure is 5 bar. Now the status is blue. All the status in the Explorer are blue, and the general status is required input complete. So when we press the next button again, we receive the message, all required input is complete, you can run the simulation now or enter more input. Run the simulation now, OK. In the screen, the control panel appears, which shows the evolution of the calculations and the final results. The computation order for the sheet, a single block, the calculation of the blocks, no errors are reported, and finally, the messages, no warnings were issued, no errors or warnings were issued, and the global status is the best one, results available. If you click now on the main flow sheet, you can check the results. For example, if you select here modify in the group flow sheet of the ribbon, you can ask for temperature, pressure, or more flow rate flags. Here you have the information, as in conventional diagrams. Also, if you select the stream, right-click, haces un clic derecho on it, and select results, you get a full information report on this stream. Vapor, liquid and solid fractions, enthalpy, entropy, density, flow, mole flow, smoke fractions, and so on. The same for the blocks. You just right-click, ask for results, and get the results from the compressor in powers. We have not introduced the mechanical efficiency, so all of them are the same. Different parameters for the calculations, and so on. Okay, and this is all. This information is enough for you to start your own example.